Hypothesis testing with two samples, two means, two proportions. So these are used when we want to test a claim that involves two groups. Here's an example of a couple of them. Do student athletes have higher GPAs than non-athlete students? Will shoppers purchase bags more often, depending on which question is asked? Would you like a bag, or would you like to purchase a bag for 25 cents? These types of questions can be answered using a hypothesis test for two samples. So let's start with the first one, two means. So the first example about GPAs, the variable here is a GPA. Now this is a quantitative variable, and we're going to summarize quantitative variables with means. So this is why we're going to be using mu. And we have two groups, so we have to distinguish them. Sometimes we're going to do them by numbering, group 1, group 2. In this case, for my example, I have students that are athletes and students who are not athletes. So rather than 1 and 2, I'll just use A for athletes and NA for non-athletes. So we have one group, one population. We have the mean of that group, the mean GPA, and then we have the mean GPA for the non-athlete groups. And we're interested in the difference between these two means. So we want to take the means of the athletes minus the means of the non-athletes. How far apart are these two means? Now this is a parameter because these two variables describe a population. I should say two populations. Now we're going to base our calculations on the distribution for the difference between sample means collected for each group. So now we're going to use an X bar for the two groups because these are represented as means for samples, not means for populations. And we're going to take one group and find the mean for the athletes. Then we're going to find the mean GPA for the non-athletes, and we're going to subtract these two. This is a statistic because these are numbers from a sample. And this in turn is going to be a random variable, since it varies depending on which samples are chosen. These are values collected from randomly chosen samples, so this is a statistic. We're interested in the distribution of all possible sample mean differences that could be collected. So now, to do these calculations, we need to make sure we have met the following conditions. These are important for us to be using the correct model and inferences. The first is the samples are chosen randomly. This is required because we're using rules of probability. So you need to have randomly chosen samples. The next we need is that the samples are independent and that they're from two distinct populations. They're not an overlapping group. The distributions of each individual population are approximately normal, or the sample sizes are relatively large. And this is exactly the same reason we had the central limit theorem before. So we need the same to apply when we're dealing with two population means. So we're going to be considering the case where the population standard deviations are unknown. So we don't know either group's standard deviation, and that those two standard deviations aren't necessarily equal to each other. This is the most common test used in practical applications. There are other tests. We're going to focus on this one. Now the formulas for the standard error, the test statistic, and the degrees of freedom can be found in your text and aren't included in this video. I encourage you to go look them up. I'm going to be demonstrating how to do all of these calculations using technology. So you should go back to the text and refer to the actual formulas used for these, but I'm going to be showing you how to do everything with technology. So now let's look at the steps for a hypothesis test. Now they're basically the same as everything we've seen before. And to keep it simple, I'm just going to use groups 1 and 2. So the first thing you have to do in any hypothesis test is you have to state your hypotheses. So if there's no difference between the groups, no difference in the means, then the two means, the mean of group 1 minus the mean of group 2, has to be equal to 0, because if there's no difference, they're equal to each other. And this is equivalent to saying the two means are equal to each other. Now remember, this is our random variable. I should say x bar 1 minus x bar 2 is our random variable. But we tend to write our null, oops, I should put it down here, sorry. Our null hypothesis, get rid of that. we're going to write it this way, typically. And in this case, the mean for group 1 is no different from the mean from group 2. Now, your alternative hypothesis with the variable is you can have these equal to 0, greater than 0, less than 0. So you'll have, as before, those same three. The mean of group 1 is higher than group 2, or we suspect the mean of group 1 is less than the mean of group 2, or the third, we're just testing to see, is the mean of group 1 different from the mean of group 2. So we'll still have the same type of thing, but now we're involving two variables, or two populations, excuse me. And so then once we state our hypotheses, our null, and one of these three alternatives, we then go out and collect our two random samples, and we calculate the means and the standard deviations for each group, find the test statistic and p-value. And as previously, the p-value will depend on the alternative hypothesis. So remember, if you have mu1 greater than mu2, in which case the center of this distribution is mu1 minus mu2, and this shaded region is our p-value, and we'll have our test statistic t. If our alternative is a less than, this is still mu1 minus mu2 is where the center is. Your test statistic here, your p-value will be on the left side. And if you have a not equals, this is going to be a two-tailed test. So that's exactly like what we've seen before. And your p-value is these two shaded regions. And then once you have your p-value, you're going to do just like you did before. If your p-value is less than your significance level, we have evidence for the alternative. We're going to go with HA. If the p-value is greater than alpha, we do not have evidence for the alternative hypothesis, and then we fail to reject, and we're going to stay with H naught. Now, two proportions. Now, for this second example, the variable is categorical. Either a person purchases a bag or they do not. For categorical variables, we typically summarize it with proportions. In this case, the two groups in my example is we had group 1, they were asked the first question. And in this case, we are going to look at the proportion of people who purchase a bag. Group 2, they were asked question 2. And so for that group, we're going to find P2. And that's in that group, the proportion of people in group 2 who purchased a bag. So now once again, we're interested in seeing if there's a difference between these two groups. Is there a difference in the proportion? So we're looking at the difference between the proportion for group 1 minus the proportion for group 2. This is describing a population, so it's a parameter. We're going to collect two random samples, determine the proportion in each sample that purchases a bag. So this is a sample proportion, the P with a hat, proportion from group 1, sample group 1. The sample 2, their proportion is P hat 2. We're going to subtract. These numbers are coming from samples, so this is a statistic. Depending on which samples are collected, we're going to get a different statistic. Hence, it's a random variable. Now, to use our probability model, we need to satisfy the following. This is very important. First, two samples are randomly collected. This happens, that's a true statement for any hypothesis test, and this is because we're using probability. We also, for this too, we need our two populations to be independent and distinct from each other. We need the number of success and failures in each group must be at least 5. So we have to have at least 5 failures, at least 5 successes of both in both groups. This is to satisfy the normal distribution situation. And then we need the population must be at least 20 times larger than the sample. And that's just because we are assuming that this is approximately roughly a binomial distribution. So with this, when we can use, this is when, if we've satisfied all these, then we can use an approximately normal distribution. And once again, you should go to your textbook and look up the formulas for the mean, the standard error, and the test statistic for this distribution. I'm going to be just demonstrating how to use technology to determine the test statistic and p-values. So in later videos, you're going to see how you use technology to find these. So now once again, similar to the first example, you're going to carry out all the same steps, but now remember you're dealing with proportions. So in this case, we have our two hypotheses. I have my null, just like with means, but now I'm dealing with proportions. So the proportion from group 1 is equal to the proportion from group 2. And then my alternatives, once again, I have three things that I could choose. I could have my alternative is group 1's proportion is less than group 2's proportion, or we suspect that group 1's proportion is greater than group 2's proportion, or we are just testing to see if the two proportions are different. Then once we state our hypotheses, we collect our data, and we're going to have an x1, which is the number of successes in group 1, out of n, and we're going to have x2, this is the number of successes in group 2, out of n2. Note, in both tests for means and tests for proportions, you do not require that you have exactly the same number in each sample. That is not necessary. But then once you have your data, then you're going to come in and do the calculations. You're going to report your p-value and state your conclusions. We have the same one. If your p-value is less than alpha, oops, that's an alpha, we have evidence for alternative. If the p-value is greater than alpha, we do not have enough evidence. And so then we stick with H naught. We fail to reject it. So they're all basically the same thing. The steps for hypothesis tests, we're just using a slightly different distribution. You still need to have everything collected randomly. You still need to have relatively good sample sizes. You have your basic conditions. And if you watch the next few videos, I'm going to show, I'm going to show examples on doing 2 sample hypothesis tests using the TI calculator. And I'll do examples for means, and then I'll do some examples for proportions.